So we'll start. What we need to find from the given, we need to find sin A and cos A, right? So now we have a formula or an identity, that is in terms of tan. Secant square theta minus tan square theta is equal to 1. From this we are going to find it out. So secant square A minus tan square A is equal to 1, right? So we know tan, substituting, right? So send it to RHS, we'll get secant square A is equal to 1 plus 4 square by 3 square. So secant square A is equal to 1 plus 4 4 16 by 3 3 is 9, right? So secant square A is equal to 9 plus 16 by 9, right? By cross multiplying it. So we'll get 25 by 9, right? So 5 square by 3 square, 5 by 3 whole square. Square and square root get cancelled. So secant A is equal to 5 by 3, right? So secant A is equal to 5 by 3. So next, okay, secant A is equal to 1 by cos A, right? So secant A is 5 by 3, 1 by cos A. Cross multiplying it, we'll get, okay, 5 by 3 become reciprocal. So 1 into 3 by 5. Cos A is equal to 3 by 5. And now we know that sin square theta plus cos square theta is equal to 1, right? It is an identity. So from it, sin square A plus cos square A is equal to 1. Sin square A plus 3 by 5, right? 3 by 5 whole square is equal to 1. So sin square A plus 9 by 25 is equal to 1. So send it to RHS. We'll get 1 minus 9 by 25, right? So by cross multiplying we'll get sin square to RHS. We'll get 25 by 9 by 25. So 16 by 25, right? 16 by 25. 4 by 5 whole square we can write it as, right? Now sin A is equal to 4 by 5. We got it, right? Okay, so we'll go with the second one. As given, cos A is equal to 12 by 13, right? So we need to find the values of sin A and tan A, right? Now we know that sin square theta plus cos square theta is equal to 1, right? From this identity we are going to find it out. So sin square A plus cos square A is equal to 1, right? So as given, cos A 12 by 13 whole square, right? So sin square A is equal to 1 minus 12 by 12 square by 13 square, right? Now sin square A is equal to cross multiply it. 13 square minus 12 square by 13 square. So sin square A is equal to 169 minus 144 by 169. So we'll get 25 by 169. Sin A is equal to root of 25 by 169. So 5 square by 13 square, right? So we can take it as whole square, right? Square and square root gets cancelled. We'll get 5 by 13. And now we need to find it out, tan A, right? So now tan A is equal to sin A by cos A, right? Sin A is, which we got it now, right? 5 by 13. Cos A is, which they have given already in the question, 12 by 13. So denominators get cancelled. We'll have 5 by 12. Tan A is equal to 5 by 12. Now we can conclude the answer. Conclusion: the values of sin A and tan A are 5 by 13 and 5 by 12 respectively. Okay, hope you got it. So we'll start with the given. So what they have given in the question, they have given two triangles, right? Triangle ABC and triangle PQR, right? And next, angle A and angle P are acute angles, right? Are acute angles, right? Now sine A is equal to sine P, and now it is the entire thing what they have given, right? Now what we need to prove, angle A is equal to angle P, right? So we'll start with the diagram of two triangles, right? Two right angle triangles. It is a right angle triangle of ABC, ABC, and another is PQR, PQR. Okay, so as they have said, angle A and angle P are acute angles, right? So we are taking angle there. Now it's an hypotenuse. For angle A it is an opposite side and it is an adjacent side of angle A, and it is an hypotenuse side, and for angle P it is an opposite side and it is an adjacent side. Okay, hope you are clear up to this. And as they have given sine A, sine ratio in the question, we are taking sine A is equal to, we know that sine A is equal to opposite side of angle A is divided by hypotenuse side of angle A, right? So sine A is equal to, opposite side is BC, right, of A. So BC by hypotenuse side is AC. Okay, we got it. Now sine P as they have given, right? So same, opposite side of angle P by hypotenuse side of angle P. So sine P is equal to, okay, sine P is equal to, opposite side of P is QR by hypotenuse side is PR. Done. So as they have given sine A is equal to sine P, then sine A is equal to sine P, right? Then the values what we got, BC by AC is equal to, BC by AC is equal to QR by PR, QR by PR. And here we don't know the exact values of these, right? So we are assuming it as K. BC by AC equal to QR by PR is equal to K, right? Now BC by AC equal to K, QR by PR is equal to K, right? BC by AC equal to K, QR by PR is equal to K, and we are dividing it. We are dividing it. So BC by AC is equal to K, Next is QR by PR is equal to K. Now send AC to the RHS side. We'll get BC equal to K AC. Okay, now QR is equal to send PR to RHS side. We'll get K into PR. Okay, we got it. And BC and QR are the opposite sides of A and B triangles, right? And now we are going to find the adjacent sides. So by using Pythagoras theorem, from triangle ABC and from triangle PQR. Okay, so we can see AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. And from this triangle we can see that PR square is equal to PQ square plus QR square. PQ square plus QR square. So we are going to find the adjacent sides. Okay, AB and PQ. So keep the AB at the same point. So send BC to the LHS side. We'll get AC square minus BC square. As it is in minus, we'll get, as it is in plus, we'll get minus. Okay, is equal to AB square. And now send the square to LHS side. We'll get square root of AC square minus BC square. We'll get AB. This is what we want, right? We want AB, not AB square. And now we are going to find PQ. So keep PQ square at the same point. Send QR square to LHS side. We'll get PR square minus QR square. It is in plus, right? We'll get minus here. So we want only PQ. Send square to this side. We'll get root of PR square minus QR square is equal to PQ. And we got adjacent sides, right? AB and PQ are the adjacent sides of a triangle, right angle triangle. So by dividing these two, we'll get AB by PQ substitute the values. Root of AC square minus BC square by root of PR square minus QR square, right? And we have the value of BC and QR, right? So substituting the values, BC and QR, okay, in the equation. So AB by PQ is equal to root of AC square minus BC square, right? BC is K dot AC, that is K into AC, KAC whole square. And next is PR square minus QR square, right? QR in the sense K dot PR whole square, right? So now we'll take root as a common root, okay? Then we'll get root of, okay, AC square minus, bring square inside for both the terms. We'll get K square into AC square by PR square minus K square into PR square, K square into PR square. Okay, now AB by BQ is equal to root of, take AC as a common term, okay, take AC as a common term, so AC square is AC square into 1 minus K square, PR square into 1 minus K square, right? So 1 minus K square gets cancelled, right? Now AB by PQ is equal to root of AC by PR whole square, right? Square and square root gets cancelled. Now AB by PQ is equal to AC by PR, right? Now which is equal to BC by QR, BC by QR. You can check it out. Then triangle ABC is congruent to triangle PQR, okay? That is angle A is equal to angle P. Can conclude, right? Conclusion, hence proved, angle A is equal to angle B, right? Hence proved that is angle A is equal to angle P. Now you can note it down.